Screen కనిపిస్తుందా మీకు? Hello? Okay. So unit 5, duals of Banach spaces. Unit 5, duals of Banach spaces. Duals of Banach space. Duals of Banach spaces. First of all, duals. Duals means what? What is duals? Duals means duals. Duals. Duals means what is our previous knowledge about duals? From Boolean algebra, we learned previously from Boolean algebra. And get, nothing but opposite of V. This is known as and get. V is known as or get. Here, and symbol and V symbol is known as duals in Boolean algebra. Or and un. And in statement also, DMS, discrete maths in first year, previous year, and or statement, truth tables also, and conjugation, and or symbols, they are already used. Those are called duals. So in this chapter, what is the duals? The set. What is the dual? The set. B means Banach space. Capital R. R means set of real numbers. R Banach space B, comma C. C means complex numbers. Complex is denoted by n star. N star means normal. N is the normal linear space. N star and is called dual space. Dual space or Banach space, the conjugate space or conjugate space. So what are the duals from Boolean algebra and arguments? The set of B, R and B complex is denoted by n star conjugate with respect to n. N is a normal linear space. This is called duals. So using duals, we'll prove one theorem. 5.3.1. Theorem. Statement. What is the statement? Let n be a finite dimensional. Let capital N be a finite dimensional అర్థమవుతుందా? ఊరికి వింటున్నారా? Let n be a finite dimensional. డ్యూయల్స్ అర్థమైందా? మన ప్రీవియస్ వాడిలో బూలియన్ ఆల్జీబ్రా అట్లాగా ఇక్కడ ఫంక్షనల్ అనాలిసిస్ లో అట్లా.
ఓకే సార్.
నార్మల్ లీనియర్ స్పేస్ NLS మీన్స్ నార్మల్ లీనియర్ స్పేస్ over a field means scalar field F. For a field F, the every linear functional on n is bounded. On capital N is bounded. BDD means bounded. The dual space n star. Here duals we are also called R power n and C0 and L1. These are all also duals. So on bounded, the dual space capital N star is finite dimensional, and N star have the same dimension. What is the statement? 5.30. Let N be a finite dimensional normal linear space over a scalar field F. Then the every linear functional on N is bounded. The dual space N star is the finite dimensional, and N and N star have the same dimension. Proof. Let N be a, let capital N is a small n dimensional let E1, E2, etc. En are the basis. The basis for n. The S is n. Then each x in, this can be written. This can be written as x equal to sigma I equal to 1 to n alpha I ei, where alpha I belongs to scalar field. F, capital F means scalar field. I equal to 1 to n. This follows that norm of x1 that equal to sigma I equal to 1 to n mod of alpha I is a norm on capital N. N is a normal linear space. Next. So, but two norms are already we discussed. Two norms are finitely dimensional or dimensional space are equal. Hence, there exists a positive m such that so norm of x1 equal to means less than or equal to m of norm of x for all x belongs to capital N, where m is a positive element. M is a positive element for I equal to 1 to n. So fi of x equal to alpha I, where x equal to sigma 1 sigma I equal to 1 to n alpha I ei. So here I equal to 1 to then a linear functional, and then further modulus of f1x equal to mod of alpha I that equal to is less than or equal to sigma I equal to 1 to n mod alpha I minus norm of 1 is less than or equal to capital M into norm of x. Norm of, for all x belongs to I. Equation number 1. So from that it follows that f equal to 1 to 3, n is bounded on hence fi. Fi belongs to n star. N star. That belongs to n star. Where I equal to 1 to n. 1 to n. 1 to n. So now show that linearly independent. Now we need to prove f1, comma, f2, etc. fn are linearly independent. Linearly independent. Linearly independent. So that purpose, what we'll do? Let us assume. Let assume sigma I equal to 1 to n beta I f of I. Beta I f of I. That equal to 0. Here, what is beta I? Beta is the scalar field, belongs to f. Beta I scalar field. So then 0 equal to sigma I equal to 1 to n beta I and fi that equal to ej minus sigma I equal to 1 to n beta I fi ej that equal to b of b suffix j. Here, what is the condition here? Since fi, since f of I ej equal to 1, if I equal to j, otherwise 0, f of I ej equal to 0, if I is not equal to j. Two conditions. So thus beta I equal to 0, that means j equal to 1, 2, etc. n. So this gives us linearly independent. This gives us linearly independent. LD means linearly independent. Next, finally we show that spans in n star. Finally, we need to prove that f1, f2, f1, comma, f2, etc. fn or fr spans in n star. Spans means the period of time. So here sigma f equal to, let us f equal to sigma I equal to 1 to n lambda I fi equation number 1. Number 2, where lambda equal to f of I equal to 1 to n, where I equal to 1 to n. Equation number 2, consider. This is this total equation number. So now x belongs to capital N. such that x equal to sigma I equal to 1 to n alpha I e I. So we'll take f of x both sides. F of x equal to sigma f of sigma I equal to 1 to n alpha I e I. This sigma outside you read, then this can be written as sigma I equal to 1 to n. Alpha is the constant scalar field, right? This can be written as f of ei. What is f of ei from 2? F of ei can be written as lambda I. Next step we will write lambda I, that equal to sigma I equal to 1 to n lambda I ei, because lambda I is the f of ei from 2, from equation number 2. Yeah. So that equal to lambda I sigma I equal to 1 to n lambda I as it is. In place of ei, I am writing fi of x, because what is the reason? By definition of f of I. Definition of f of I, right? So that equal to sigma I equal to 1 to n lambda I f of I for all x belongs to capital N. So this shows that this gives us n star is finite dimensional. N star is finite dimensional. N star is finite dimensional, and the dimension is n. That dimension is n. Hence prove. Second theorem, 5.3.2. Theorem 5.3.2 theorem. 5.3.2. So statement. What is the statement? Let C0 denote the linear subspace. Let C0 denote the
linear subspace which consists
of the all
the sequences that converges to 0.
Then C star equal to L1.
L1.
Denote the linear subspace consists of the sequences that converges to 0. Then C star equal to L1 star. We need to prove C star equal to L1 star. What is the C star and L1 star? Do else nothing but, right? So proof. Let define delta of small delta m comma n that equal to 1, 0 if m equal to n. Otherwise, if m is not equal to n, is 0. So here en, let en, what we are taking, delta 1 comma delta 2 etc. delta n. Then so on. Then en what we are taking, 0 comma 0 etc. 1, 0 comma 0, etc. This is the basis. This one we known as nth place. Nth place. Nth place. So let x equal to alpha I. Let x equal to alpha I. Belongs to C0. Belongs to C0. So delta, undefined delta n equal to I equal to 1 to n. I equal to 1 to n. Alpha I E I. Alpha I. So it follows that norm of x minus Sn infinity. It follows us norm of x minus Sn infinity. That equal to supremum of mod alpha I such that where I equal to 1, 2, etc. n. N plus 1, comma, n plus 2, so on. Next. So the n plus 1. So alpha I is converges to 0. It follows that epsilon greater than 0. Alpha I converges given converges to 0. Converges to 0. Epsilon is greater than 0. There exists a positive m. There exists a positive m, capital M, such that ST means such that norm of x minus n, norm of x minus Sn less than epsilon for all n is greater than or equal to 1.
N.
For all n is greater than or equal to capital M. Right. So let f belongs to C0. Let Bn that equal to f of En. Consider equation number 1 because we will use this result further. Right. Then we need to write mod of x minus sigma I equal to 1 to n.
Alpha I.
Beta. That equal to separate that up. Now mod of f of x
F of x minus
sigma I equal to 1 to n. 1 to n. We can write it as alpha equal to f of ei from 1 we wrote. That equal to f of x minus sigma I equal to 1 to n alpha I ei. So that equal to mod of f of x minus delta n, x minus delta n, less than or equal to, separate the norm of f minus norm of f, that is less than epsilon into norm of f, into norm of x minus delta n for small n greater than or equal to capital M. Next, this shows that f of x, alpha shows. Now we show that beta of n is L1. We need to prove that beta of n equal to L1. For this purpose, define lambda I equal to 0 if beta I equal to 0. If beta I equal to 0, mod beta I by beta I, mod beta I by beta I. If beta I is not equal to 0, because this is consider equation number 2, because we'll use the result. What is the result here? Lambda I, beta I can be written as mod beta I, This result will be used in further for definition. So let xn equal to sigma. Let xn equal to sigma I equal to 1 to n lambda I ei. It follows that norm of x n less than or equal to 1. Further, we'll take this, apply f function both sides. What we will write? F of xn can be written as f of sigma I equal to 1 to n lambda I ei. Again, this can be written as f we will take inside. What will write? I equal to 1 to n. Lambda I is as
Lambda I
this
into
I
f of ei.
we are writing f of I. Okay, f of e. That equal to sigma I equal to 1 to n as it is. Lambda I as it is. Written as lambda I beta I. Lambda I beta I from 1. From equation number 1. So that equal to sigma I equal to 1 to n.
1 to n.
This
Lambda I
lambda
beta
I beta I already we know from equation number 2. What will get? Mod
b.
beta I. Okay. So this from equation number 2. Next further. Therefore, sigma 1 to n mod beta I equal to mod f of xn f of xn that equal to, this can be written as mod of f norm of xn. What we wrote? I equal to 1 to n beta I f of xn. This is xn. Mod of f of xn suffix. This what we wrote? Norm of f. This is norm of f plus norm of xn. What we define norm of xn is less than or equal to 1. Norm of xn before we defined less than or equal to 1. Then what we will write? This is less than or equal to 1 means norm of f. Just rest is norm of f. So we have the inequality. This can be written as sigma I equal to 1 to n less than or equal to norm of f. So let us define T C0 star to L1 as follows. So by definition of T, easy to verify, T is 1 1. T is 1 1 1 comma 1 means 1 1 function and linear. T is 1 1 and linear. That means we have to show that we need to show that T is onto. We need to prove that or show that T is onto, means onto function. That purpose what we are taking, let beta I belongs to L1. Beta I belongs. It follows that implies it follows that I equal to 1 to n sigma I equal to 1 to infinity alpha I beta I converges to absolutely converges to converges to converges subjectively for each x equal to alpha n
which is belongs to C naught.
belongs to C naught. C naught is the dual. So again, define F on C naught. C naught as follows. So f of x equal to sigma I equal to 1 to infinity alpha I beta I. So this follows. Here this follows f is bounded linear C naught. Hence f belongs to C naught. F belongs to C naught. C naught star. By definition of Fi follows that. By definition of Fi follows that f of En equal to beta of n. So I equal to 1 to n alpha I beta I converges to absolutely. It follows that norm of f of x. Here follows that norm of f of x is less than or equal to sigma I equal to 1 to n mod beta I for norm of x infinity is less than or equal to 1. Norm of x suffix infinity or n is also less than or equal to 1 by default. So hence it follows that norm of f is less than or equal to sigma I equal to 1 to n mod beta I that equal to norm of beta I that equal to T of f, norm T of f. So thus norm T of f equal to norm f. So T is an isometric and isomorphism. C star is onto L1 star. Hence the theorem. General ga manamu onto prove cheyalante em chestam lower classes previous knowledge. F of x is any function is given. First one satisfy chestam. Onto ante meaning endi? The range should be equals to its codomain. Means f of x equal to y prove cheyalam. Okay. F of x equal to y prove chestam. Adi onto avutundi. Ikkada manam em chestam ikkada by definition dual space తీసుకొని dual space లో T of f equal to f అని prove చేస్తున్నాం. Then C star is onto on L1. Okay, hence C star gives L1. C star and L1 are the duals. Understood? అర్థమైందా? రెండు థియరం చాలు. నెక్స్ట్ దీన్ని ఒప్పుకుందాం. ఇంకో చాప్టర్ చేద్దాం. హాన్-బనాక్స్ థియరం. నెక్స్ట్ యూనిట్ 6 హాన్-బనాక్స్ థియరం. యూనిట్ 6 హాన్-బనాక్స్ థియరం. HAHN బనాక్స్ థియరం. ఈ హాన్-బనాక్స్ థియరం ఒకటే ఉంది కానీ లెమాస్ దీని హాన్-బనాక్స్ థియరం ప్రూవ్ చేయాలంటే ఫస్ట్ we need to discuss about partially ordered set. What is partially ordered set? Next Jones lemma. Next one definition. 3 we need to discuss. Okay, do you have any idea partially ordered set?
No, sir.
Okay, I will teach partially partially ordered, partially ordered set. Definition, write down. Let X, capital X, be a non-empty set. Non-empty set satisfies the non-empty set satisfies the following axioms. Axioms are postulates or properties. What is the first axiom? Set relations lo idea on the relations lo manam discuss chestunam previous reflexive relation, next the symmetric relation, next transitive relation. If these three are satisfied, equivalency relation previous okay. The reflexive relation means x, x equal to x, or a equal to a, b equal to b. Symmetric relation, a equal to b, b equal to a. Then that is called symmetric relation. What is transitive relation? Previous x equal to y equal to z, then x equal to z. That is the transitive relation. Here the same way we'll discuss, but we are using symbol. Using the symbol less than or equal to. Here first condition property, x is less than or equal to x. Is it there?
No, sir.
Sound in x is less than or equal to x. It belongs to capital X. This is known as reflexive. Next, second one. X is less than or equal to y. X is less than. Y రాస్తామంటే ఇది x అయిపోతుంది. X less than or equal to
Capital Y.
Small letters.
Okay, sir.
Small letters. X less than or equal to small x y, comma y is less than or equal to small x. For all x comma y capital X. This is known as symmetry and the anti-symmetry. Symmetry ki anti-symmetric difference x equal to y, y equal to x.
Yes, sir.
The anti-symmetric property. Anti-symmetry. Third condition. X less than or equal to y. Less than or equal to z. For all x comma y comma z. Capital X. This is known as transitivity.
Sir, ఎవరో mute చేస్తుండి చెప్పండి సార్. Some sound is very much disturbing.
Sound is coming.
Mute చేయమని చెప్పండి సార్.
ఎవరైనా సౌండ్ వస్తే కొంచెం మ్యూట్ చేస్తారా? బయట సౌండ్ వస్తుంది. This is known as transitivity. This partially ordered set, also known as complete, totally ordered set, also known as totally ordered set, comma completely ordered set, or chain. Understood? Partially ordered set. Next, I'm going to Jones lemma, because connection with this partial order. Jones lemma. Jones lemma. సౌండ్ వస్తే కొంచెం మ్యూట్ చేయండి. ఎవరో మరి నాకు. If x is a partial ordered, Jones lemma. If capital X is a partially ordered, X is a partially ordered set, which every chain, every chain,
Madam, some sound, Bhagirachi madam, some sound mute చేసుకోండి please.
every chain, subset has an upper bound, then X contains, then capital X contains, then X contains maximal element, maximal element means at least one element. What is the Jones lemma? Because this will use in further. Jones lemma. If X is a partially ordered set, just now only we discussed about partially ordered set, which is every chain or totally ordered set. Subset, an upper bound. Then X contains the maximal element, at least one element. So another 6.4.1 definition. 6.4.1 definition. 6.1. So let M and M not be linear subspaces. So let capital M and M not be the linear subspace of linear subspaces
Of a real norm.
of real normal linear space. Real NLS, I'm writing NLS, normal linear space.
Space. Okay.
Space such that, what is that? M is subset of M naught. Yeah, capital M is subset of M naught. What is subset? Subset means, I'm writing subset is coming less than thing. I will write on. M is subset of M naught. Subset means, now all the elements of capital A have the capital B. Capital B need not be in capital. Or all the elements of M in M naught. So all the elements of M naught need not be in M, right? That is, M is subset of M naught. So let F M to R. R means set of real numbers. Is linear. F can be extended. What we'll write? F can be extended F naught, and M can be extended M naught tends to capital R. What we did? This is also a linear. What we did here? F can be extended. F naught. M can be already extended. M to M, no linear. M naught. That result we will write. So such that, using these two equations, what we are writing here? F of M, F naught M equal to F of M. F naught M equal to F of M. For all small m belongs to capital M. Understood? M and M naught be a linear subspaces, real normal linear space, such that M is subset of M naught. What is the first equation? F is M to R. R is a set of real numbers. Real. F naught M naught to M naught. Both are linear, such that F naught M equal to F of M. Next theorem. So lemma. We need to prove. For proving Hahn-Banach's theorem, we need to prove lemmas. Lemma for one is real numbers, another is complex numbers. Real numbers will be first. So 6.4.2. Let M be a linear subspace statement. Lemma. What is lemma? Lemma is a sub-theorem of the main theorem. Using this only, we'll prove Hahn-Banach's theorem, right? Let capital M be a statement. Let capital M be a linear subspace of linear subspace of linear subspace of real normal linear space, real normal linear space, linear normal. F is a real valued, F is a real valued, real valued, continuous linear functional, CTS continuous, LF means linear functional on capital M. On M. If x0 is not a vector, if x0 is not a vector, x0 is not a vector in M, in capital M, and if M0 is a linear subspace, M0 is a linear subspace, linear subspace, linear subspace, generated by x0, generated by x0 in, generated by x0 and M. Then F can be extended to, then F can be extended to, F can be extended to a continuous linear functional, continuous linear functional, F0 to M0, come M0 in, such that norm of F0 equal to norm of F. What is the lemma statement is given? Once again, let M be a linear subspace of real normal linear space. NLS means normal. F is a real valued continuous linear functional on M. This is M. If x0 is a vector in M, if x0 in a linear subspace generated by x0 and M, then F is a extended to continuous linear functional F0 to M0. F0 to M0. Then proof. So proof. What is the proof? Let X belongs to, let x0 belongs, x0 does not belongs to capital A. Then what we'll write? M0 equal to x0 plus capital M. So every element of M0 can be written uniquely in the form of, that implies what we write, x equal to alpha x0 plus small m. Small m. Here small m belongs to capital M. So alpha is a, what is alpha here? Alpha belongs to capital F, nothing but scalar field. Define function F0. Define function F0 on M0, on M0 as follows. As follows. That means F0x, that can be written as F0x equal to F of M plus alpha R0, alpha R0. What is R0? R0 is a real number, real number chosen such that way, chosen such that way such that way norm of f naught equal to norm of f. Norm of f. So by definition itself, so f naught is a linear. F naught is a linear. That is a linear means what we'll write? F naught m, that equal to f of m. F of m. For all small m belongs to capital M. So we need to prove that norm of f naught equal to norm of m. By definition of a norm of a functional, what we'll write? Norm of f naught can be written as supremum of f naught x, supremum of f naught x mod, such that x belongs to capital M, such that x belongs to capital M for all norm of x is less than or equal to 1. That means capital M is less than or equal to m naught. So that equal to supremum of mod of x such that x belongs to capital M. X belongs to m naught. X belongs to m naught. M naught. For all norm of x less than or equal to 1. Less than or equal to. So since f of x equal to f naught x for all x belongs to m, that equal to norm of f. What we prove? So norm of f naught equal to norm of f. Thus norm of f less than or equal to norm of f naught. Equation number 1 consider. We need to use further this. So we choose an R naught is the R naught in such a way mod of f naught is less than or equal to norm of f. Next page. So here let x1 comma x2 be in M. So that implies f of x2 minus f of x1 can be written as that equal can be written as f you will take common mod of x2 minus x1. What is the reason? Linear. It is a linear. That less than or equal to, that can be written as norm of f. And in the linear, we are writing in normal linear form. Norm of f and norm of x2 minus x1. So is less than or equal to norm of f as it is. Norm of f as it is. That means norm of x1 plus x0. Minus norm of x2 plus x0. What I did here, understood? Adjustment, nothing but. I read one. This is norm of f as it is, right? Here, norm of x2 minus x1. This adjustment I am writing here. Observe. Norm of x2 plus x0 I am taking. Norm minus again norm of x1, norm of x2 plus x0, norm x0, because here in between minus is there, plus x0 minus x0 cancelled. For adjustment I wrote this can be written is less than or equal to norm of f as it is. This can be written as norm of x1 plus x0, x1 plus x0, norm of minus this norm is whole, this f is whole thing. That norm of f I am taking inside. That's why I applied for first one and next also. Norm of f into within the norm of x2 plus norm of x0. This norm I applied. Consider A and B. I applied norm of f first one and norm of f second one. That implies.
ఇందులో ప్రింట్ మిస్టేక్ ఉందా సార్? ఇది ప్లస్ రాశారు కదా సార్ ఇందులో?
ప్లస్ ఉంది, మిస్టేక్ ఉంది సార్, అందుకోసం నేను చెప్పేది.
థ్యాంక్ యూ సార్.
ప్లస్ చాలా మిస్టేక్లు ఉన్నాయి, అన్ని మళ్ళీ చేసి సెట్ చేసి మీకు చెప్పాలి. ప్లస్ కాదు అది మైనస్, ఎందుకంటే ప్లస్ అంటే అడ్జస్ట్ కాదు, చూడండి కావాలండి. ప్లస్ మైనస్ క్యాన్సిల్ అయిపోతుంది, 2x0 వస్తుంది ప్లస్ చేసి.
అవును సార్.
f of x0 x1 minus norm of f again norm of x1 plus x0. ఇక్కడ కూడా మైనస్ పడింది, ప్రింట్ చేసుకోండి. ప్లస్ అది is less than or equal to
x1 plus x0.
x1 plus x0, norm of
6.4.22 లైన్ లో సార్ అది.
అవునవును.
థ్యాంక్ యూ సార్.
x2 plus x0 minus f of x2, equation number 2 consider. So inequality, this follows x1 and x2 in M, therefore the supremum of this minus f of x1 minus norm of f, so norm of x plus x0
supremum of minus of f of x ఉంది సార్ ఇందులో.
అవును,
it should be x1.
x1 అవి డిలీట్ చేసేస్తాం అన్నమాట, రిమూవ్ చేసేస్తాం. డిలీటింగ్ x1 x2 అన్ని డిలీట్ చేసి అన్ని x లో రాస్తాం. x plus x0
x రాసుకోవాలా సార్ ఇప్పుడు?
అన్ని x రాస్తాం.
ఓకే, థ్యాంక్ యూ అండి.
equal to infimum of x belongs to capital M, norm of f, norm of x plus x0 minus f of x. We are removing 1 and 2 for x. This consider equation number 3. Next, so let first one name left-handed, supremum name let A, LHS left hand side name A and consider this one. RHS the infimum memo RHS ni B and consider this one. Left, this is so in view, so here A is less than or equal to B, that means LHS A, RHS B, less than A is less than or equal to B. So choose real number, or not, such that A less than or equal to R naught is less than or equal to B. Means this meaning the R naught is lies between A and B. A and B, what is A? Supremum of. B is infimum of something. No? So this follows that. minus f of x minus norm of f. So norm of x plus x naught, x plus x naught less than or equal to r naught, less than or equal to norm of f, norm of f, norm of x plus x naught minus f of x for all x belongs to capital M. So that implies here norm minus norm of f, norm of f, norm x plus x naught, x plus x naught is less than or equal to r naught plus f of x, because this minus f of x we are taking inside, right? That becomes plus f of x is less than or equal to norm of f, norm of x plus x naught. No?
For all x belongs to capital M.
No, for all x belongs to, this is continuation. This is. So if here three conditions will arise. If alpha is greater than 0, alpha is less than 0, alpha, no? Alpha is greater than 0. Here alpha is greater than 0. Consider the inequality. Phi is greater than 0. Consider the inequality. Inequality. What we are taking from 4. Norm of f. X divided by alpha. X by alpha plus x naught is less than or equal to r naught. R naught plus f of x by alpha.
A.
Alpha x by
Sorry,
a.
alpha.
Alpha or a. That is a scalar field. Norm of f means, that means x by alpha or a, x by alpha plus x naught, x naught. So actually ఇది ఏ ఉండాలి, ఆల్ఫా అని రాశారు. సరిపోనే లేదు, ఏదైనా కాన్స్టెంట్ మనం కన్సిడర్ చేసేది. సో
ఏ ఆల్రెడీ యూజ్ అయింది కదా సార్, అందుకనే రాశారేమో సార్. ఏ అంటే ఇది మనం
కన్ఫ్యూజన్, మళ్ళా రెండు క్లాషెస్ అవుతాయని ఆల్ఫా అంటే.
ఆల్ఫానే సార్ అది.
ఆల్ఫా. సో ఆల్ఫా నెక్స్ట్ ఈ ఆల్ఫాని ఏం చేసేసుకున్నాం, ఆల్ఫా ఆర్ నాట్ ప్లస్ ఎఫ్ ఆఫ్ ఎక్స్, alpha x less than or equal to norm of f, norm of x plus alpha x naught. So that is f naught x plus alpha x naught is less than or equal to norm of f into norm of x plus alpha x naught, equation number 5. So consider the inequality again, alpha less than 0, alpha there is less than 0. Consider the inequality minus norm of f, norm of x by alpha plus x naught is less than or equal to r naught plus f of x by alpha. So alpha less than 0, it follows again minus alpha, norm of f, norm of x by alpha plus x naught is greater than or equal to alpha r naught plus alpha f x by alpha, that equal to a r naught plus f of x, that equal to f naught x plus alpha x naught. That means that implies minus alpha, norm of f that equal to norm of x plus alpha x naught whole divided by mod alpha is greater than or equal to f naught x plus alpha x naught. So by cross multiplication greater than that, we will write in the here what is the minus alpha is nothing but, suppose if you take mod that is positive, it will become no. That's why we can write this above equation can be written as f naught x plus alpha x naught less than or equal to norm of f norm of x plus alpha x naught, equation number 6. So from 5 and 6, from 5 and 6, we obtain what will f naught x plus alpha x naught less than or equal to norm x plus alpha x naught for all x belongs to capital M, alpha belongs to scalar field or real number. So that implies, that means minus f naught. This follows minus x is f naught x belongs to no need. This one. Hence, you can write direct step. Hence, norm of f naught x plus alpha x naught less than or equal to norm of x plus alpha x naught, equation number 7 consider. So here that is f naught x is less than or equal to norm f and norm z. F naught z less than or equal to f of norm f norm z for every z in m naught. Similarly, so norm of this can be written as, so norm of f naught that equal to supremum of norm f and norm z such that norm z is less than or equal to, in place of x nothing but he took z, that is considered that equal to norm of f. Consider equation number 8 from 1, 8, from equation number 1 and equation number 8 we obtain the result. Result means we obtain the result. He is f of less than or equal to 8. What is the result? Norm of f equal to norm of f naught. Hence prove. Right? This is what we prove. Lemma for real cases. So 6.4.3. 6.4.3. Another lemma is there. This is complex case. Small one is there. Can do, this is a homework. Now we will do Hahn-Banach's theorem. These two will use in Hahn-Banach's theorem. That is 6.4.4. The Hahn-Banach's theorem. Banach's theorem. What is the statement? Let capital M be a linear subspace of normal linear space N, and let F be a functional defined on M, then F can be extended then F can be extended. F can be extended
To
to
a
a
function.
functional F naught. మీరు హార్న్-బర్నౌక్స్ థీరం ప్రూవ్ చేయాలంటే రియల్ కేసెస్ రాసి సిమిలర్లీ హాల్ రాసేసి ఇది రాస్తే కూడా ఫుల్ మార్క్స్ ఇస్తారు. Extended.
First, we have to prove two lemmas.
Definition 6.4.1 definition is there. First
Yes,
definition.
sir.
Next lemma. Similarly for complex cases also.
Okay, sir.
So extended functional.
MS proof కూడా రాయాలి సార్ అప్పుడు.
కంపల్సరీ ప్రూఫ్ రాకపోతే ఫుల్ మార్క్స్ ఇవ్వాలి. ఒక్కటే కాంప్లెక్స్ అవసరం లేదు. రియల్ కేసు ఉంది, కాంప్లెక్స్ కేసు ఉంది కదా.
రెండిట్లో ఏది రాయాలి సార్?
రియల్ కేస్
2 లేకపోతే 6.4
6.4.2 ఇప్పుడు మనం డిస్కస్ చేసింది.
ఓకే
6.4.1 6.4.2 రాసిన తర్వాత సిమిలర్లీ ఫర్ కాంప్లెక్స్ ఆల్సో దిస్ కెన్ ఇంప్రూవ్డ్ రాసి ఇప్పుడు నేను రాసేది రాయాలి ఫంక్షనల్. ఇది కొంచెం చిన్నగా ఉంటది అన్నమాట, ఎందుకంటే అవే పెద్దవి ఉంటాయి మధ్యలో. ఫంక్షనల్ ఎఫ్ నాట్.
ఎక్స్క్యూజ్ మీ సార్,
మళ్ళీ 6.44
క్వశ్చన్ ఇచ్చారు కదా సార్, అసైన్మెంట్ లో కూడా ఈ క్వశ్చన్ ఇచ్చారు సార్. అప్పుడు లెమ్మా డెఫినేషన్ తర్వాత లెమ్మా మొత్తం రాసాము.
అసైన్మెంట్ ఇస్తే మొత్తం రాయాలి, ఎందుకంటే చూసి రాయాలి కదా.
అది లెమ్మా కంప్లీట్ చేసాం సార్. దాని తర్వాత ఇప్పుడు మీరు 6.4.4 కూడా రాయాలా?
రాయాలి. ఇదే అసలు తీరం. ఈ తీరంలో అవి ఏం చేస్తామంటే యూజ్ చేస్తామన్నమాట. బై 6.4.2 ఫర్ లీనియర్ కేస్, 6.4.3 ఫర్ కాంప్లెక్స్ కేస్ రాసి ప్రూవ్ చేస్తాం.
ఓకే సార్.
అది ప్రూఫ్ చేసిన తర్వాతనే మేము థీరం రాయాలి.
ఇప్పుడు ఇది రాసి అది ప్రూవ్ చేసినాక మెయిన్ థీరం, ఎందుకంటే ఆ ప్రూఫ్ ఇందులో యూజ్ అవుతుంది అన్నమాట.
ఓకే ఓకే, థ్యాంక్ యూ సార్.
ఆన్ ద స్పేస్ n such that norm of f naught equal to norm of f. Proof. So let B is a set of all extensions. B be the set of all extensions F2 functional G. F2 functional G with the same norm defined. With the same norm defined on subspace contain M. So now define the relation less than or equal to as follows. Small g1 less than or equal to g2. Domain of if domain of g1 is contained in domain of G, in the domain of G2. That means G1 of X equal to G2 of X on the domain of G1. So it is B is a, then B is a partially ordered with the above partial order relation. So let C be the chain. Let C be the chain. C be the chain in B. B is nothing but Banach space. C be the chain. Define the linear functional G as follows. Define linear functional G as follows. So the domain of G, the union of the domain of G dash for all G belongs to it. That is, first one is G dash, yes, G dash for all G belongs to capital B. So X is the domain of define capital G of X equal to small g of X. G of X, where G belongs to C. C belongs to C means complex case. So G belongs to B. G belongs to B. Then G belongs to G. Then C is the chain functional G, well defined. It is G is an upper bound. So G is an upper bound for the chain C. G is the ట్వంటీ పేజెస్ కంటే ఎక్కువ రావట్లేదు, చెప్తాను చూసుకోండి. ఇది 20 పేజెస్ వస్తుంది నా దగ్గర ఉన్నది. ఎక్స్ప్లెయిన్ చేస్తాను చూడండి. G is an upper bound for the chain C. Since chain C is a arbitrary follows every chain beta has upper bound by Jones lemma. Jones lemma discuss చేసుకున్నాం కదా.
Yes, sir.
Jones lemma by Jones. This is prove that domain of F naught in N. So let M naught be the domain of F naught. We claim that M naught equal to N. Here M naught is not equal. Suppose M naught is not equal to 1. Then there exists X naught in N such that X naught belongs to M naught. Right? So M dash that is X naught plus M is a linear subspace of N such that which contains M naught and X naught by lemma 6.4.2 for real case and lemma 6.4.3 for complex case. F naught can be extended F naught. F naught dash. Further, F naught dash belongs to B. Then our contradiction of maximality F naught in beta. So hence M naught equal to N. This completes the proof. Otherwise, first we
capital B,
capital B.
Prove and
మనం ఫస్ట్ డెఫినిషన్ 6.4.1 డెఫినిషన్. నెక్స్ట్ రియల్ కేస్. నెక్స్ట్ ఇది స్టేట్మెంట్ వచ్చిన ఇది రాసిన తర్వాత ఇప్పుడు ఇక్కడ 6.4.2 దగ్గర ఇది అరేంజ్ చేస్తే వస్తుంది చూద్దాం. క్లియర్ ఆల్ డ్రాయింగ్స్ ఇప్పుడు వస్తుంది. ఇప్పుడు వద్దాం. ఇది ఒకటి మిగిలింది ఇక్కడ రాసినట్టు ఇది అన్నట్టు. Thus M naught M dash equal to X naught plus capital M is a linear subspace of N. Is a linear subspace of N. N and which contains M naught and X naught. M naught and X naught by lemma 6.4.2 real case and
complex case.
6.42 కాంప్లెక్స్ కేస్. ఇక్కడ ఇచ్చేసి కాంప్లెక్స్. ఇప్పుడు ఆల్రెడీ మనం ముందే ఇది రాసేసాం 6.4.2 ప్రూవ్ చేసి సిమిలర్లీ కాంప్లెక్స్ కేసెస్ అని ఇక్కడ రాసేస్తే అప్పుడు ఫుల్ మార్క్స్ వస్తాయి. ఒకటన్నా రెండు రియల్ కేసులో అన్న రాయాలి, కాంప్లెక్స్ కేసు అన్న రాయాలి. నేను ఎందుకంటే రియల్ కేసు ఏమో పెద్దగా ఉన్నది, కాంప్లెక్స్ కేసు చిన్నగా ఉన్నది. మీరు అది అర్థమైతే అది ప్రాక్టీస్ చేయండి, ఇది అర్థమైతే ఇది ప్రాక్టీస్ చేయండి.
ఓకే సార్.
ఇది ఒక కేసు అయితే రాయాలి కంపల్సరీ.
ఓకే సార్.
Okay. So tomorrow we'll meet same time 4:30.
Okay,
Okay, sir. Thank you, sir.
sir, when we have to submit our assignment, sir?
మీరు విజయ్ అడగాలి, ఎందుకంటే ఆయన రెగ్యులర్ చేస్తాడు కనుక.
Okay, sir.
విజయ్ చెప్తాను.
సార్ ఇందులో ఇది లెమ్మా హ్యాన్బెనాష్ థియరం వచ్చేసి 5 మార్క్స్ లో ఇచ్చినారు సార్. అందులో వచ్చేసి 5 మార్క్స్ లో ఇచ్చినారండి.
అయితే ఇవి వచ్చాయి, ఇప్పుడు మనం డిస్కస్ చేసుకున్న స్టేట్మెంట్స్ అట్లా రాస్తే సరిపోతుంది.
అంటే సార్ అంటే లెమ్మాస్ అవన్నీ
ఏం అవసరం లేదు, ఆయన కంపల్సరీ ఇది 20 మార్క్స్ క్వశ్చన్ యాక్చువల్.
ఐ సీ.
సార్ ఇవే ఇంపార్టెంట్ క్వశ్చన్స్.
10 మార్క్స్ ఉన్నాయి సార్. అంటే
మీ క్వశ్చన్ పేపర్ లో ఉంది అనుకోండి, నేను చెప్పేటి ఓన్లీ ఇంపార్టెంట్ తప్ప నేనేమి ఎందుకంటే మనకు ఉన్న టైం తక్కువ. మళ్ళీ అందులో డిస్టెన్స్ ఒకటి 10 చెప్తే గానీ ఒక 5 అర్థం కాదు, 5 చదవాలనుకుంటే 2 చదవగలుగుతాం.
ఓకే, థ్యాంక్ యూ.
థ్యాంక్ యూ.
Thank you, sir. Thank you.
Thanks, sir.